Okay. Good morning, everyone. Thank you for connecting in today. I would just like to start this webinar by introducing you to Unikaksha. Okay. So we are an online education providing platform that helps students and working professionals upskill themselves in their tech career with the help of top mentors and industry relevant curriculum. So far, we have had a positive impact in careers of 5,000 plus students. And today, with this Guru class, we hope to help you in the same manner. Okay. Now, let me introduce you to the trainer for today, which is Swati. And so I'll just give you a brief introduction about Swati. She has overall 8 years of experience in Java FSD, web development, 2 years of experience as a certified trainer in Java, web, Python, data science, handle classroom delivery and curriculum development for K-12 segment for web and Python, and Java FSD curriculum development and training for working professionals. I would like to hand over this webinar to Swati now to take it over from here.
Hello, good morning on a Saturday morning, right? So, hi everyone, this is Swati Yadav, and I extend a warm welcome to you guys in our session today in our Guru class. Now, today's topic, as you might be already aware of, is we'll be talking about some sorting techniques, right? And yes, the time that we have, it's kind of limited, but we'll try to talk about various trying to cover up the topic as well. Now, if I ask you guys, have you guys ever wondered, how the products in an Amazon cart or in any other, e-commerce website, they get sorted? Do you see that when you apply filters, they get sorted? Like maybe from low to high or high to low? Yeah. Or maybe like alphabetically, or you have high preferences and so on. So there, the sorting algorithm, it plays a vital role for such websites where you have an enormous amount of products listed, and you have to make your customer interactions easy. Just give me a moment. I see it's quite low. I hope now it's coming all right? Okay. So a sorting algorithm, again, what is sorting, or what is the process of, sorting? So sorting, basically, it refers to, or you could say, is the process of arranging a list of sequences of given elements that, can be like numbers, string, etc., or data into any particular order. So which may be ascending or descending. Okay, so it's basically useful whenever we want our data to be in an ordered form. Okay, to make our lives easier, we have sorting algorithms to perform the given tasks as well of, sorting our data. And the sorting algorithms, they are defined set of rules, algorithms that they are defined set of rules, or you could say processes or procedures by which we can easily sort a list of, a list or maybe an array of an items, So now in our today's session, we are going to learn about sorting, what is sorting, and discuss about it. So that is what our agenda is, Some of the few sorting algorithms that we think that every programmer should know. Okay, so this deals about what is sorting, what are, different sorting algorithms, what is the importance of sorting algorithm. Now, what do you think is an importance of a sorting algorithm? Anyone? What do you think? What is the importance of sorting algorithm? I want you guys to make use of the Q&A section, the chat section as much as you can, you know. Let's keep it interactive. I don't want it to be a one-sided session. It's a very basic question. What do you think, or where is it useful for you guys? You know, I gave you an example. You can take the same example. You can think something around it. Okay, cool. To find things easily. Yes, valid enough. Large and small numbers. Yep. Yes, hi Ragul. Hi. The arrangement of data in preferred order is sorting. Okay. I'm not asking about what is sorting. I'm asking about why do you think that it is important to have sorting, or, you know, to learn about these sorting algorithms. So you see that these sorting algorithms, they are the backbone, you know, of many programming solutions. Now, they are widely used in computer science due to the following reasons. And what could be those reasons? They reduces the computational complexity of various problems. You know, you sort an array and then you perform an operation onto it. It becomes quite easy. One thing, that it reduces the computational complexity of various problems. It makes your raw data simpler and meaningful to analyze. Okay, so the raw data that you have, and if you want to analyze that raw data, if it is in an unsorted, you know, kind of just in a haphazard manner, would you be able to look through it and find some meaningful information out of it? No, but when you sort it and you put it in a proper manner, then you're more able to analyze it even better. Okay, so because after sorting any list or array, we get our data in an ordered form. Hence, it becomes simpler to analyze it. The third is that making it easier to implement search algorithms. Sorting and searching, they go hand in hand. Okay, so if you have the sorted data and if you want to perform a search operation again, the search operation, it becomes simpler now. Okay, you might have heard of searching as well, right? So now to find or retrieve an item from a data set efficiently and, you know, perform operations on them. So sorting, it also helps us to you know, solve most of the problems which required an ordered set of data. Again, coming to the same point of having the order, you know, in your data set. So it is easier for us to check our, you could say, let's say if you have a data of students, or you have just your data and it's just sorted, you know, you'll see your scores, your marks from any list, because the list is now it's sorted, you know. Either it is sorted lexicographically, that means it's sorted, you know, with the names. Now you have been to college, I suppose. You must have been to school, yes. Now there you see you have the attendance register. In the attendance register, you'll see all of the names, they are sorted, right? So we'll start from A and then we'll go to Z. So it becomes easier for anyone to go through that particular lexicographic list of names and find a particular student. That is again, you know, part of sorting, or that is also an example of sorting. Okay. Or you can also have based on numerical values, like maybe based on employee IDs, or, you know, roll numbers based on that, or customer IDs, you can have it. We see it every now and then, but sometimes we are not able to identify it, right? So this is the overview that I gave you of sorting, that how it looks like, you know. Now, examples, other examples to include over here. What do you think? Anyone? Is my voice clear? Am I audible to everyone? Can someone from the panelist let me know? Yes?
Yes, Swati.
Okay, so Hamza, I need you to, you can connect again if you're facing any problem. So now some of the real life examples that you will see, of sorting are dictionaries, right? Dictionary, is it a sorted book? Everything is sorted inside it. The dictionary, it stores words in alphabetical order. Yep. So that searching for any word becomes easy. See, sorting and searching going hand in hand. Now, telephone book. We have a telephone directory. Now we don't have it. But back, a few years into the past, we had telephone directories. We also have it now, but I think everything is now on the Google, right? Now, e-commerce applications. So while shopping through any e-commerce websites, you preferably tend to sort the items, right? So I'm going to buy maybe like earphones and I want something cheaper. So I'll go from low to high over there, right? Something like that we do. So this is all the examples of sorting. Okay. This is what your sorting basically comprises of. Now, there are two other terms which come when we talk about performance. That is time and space complexity. Anyone who can let me know what you understand by time complexity? Anyone? You might have heard these terms, right? Time complexity, space complexity, ON square. None? Okay, cool, no problem. Okay, I've got one. I've got two. No, ma'am. Acha. Ma'am, ये एक type का algorithm है. Acha, okay. Let me talk about it now. So, time complexity. Time complexity in the programming world, it simply, means the measure, or you could say, it measures the approximate time which is, taken by a piece of code or an algorithm to execute, to run, okay, to finish basically based on the size of input that we pass. So time complexity, it just means that it's the measure of the time which is taken by a piece of code or an algorithm to execute. ठीक है, पूरी तरीके से finish होने में, execute होने में, how much time does it need? So it just means that. Okay. Now the time complexity, it does not give us the exact measure, you could say. It does not give us the exact measure of time, but it gives us an overall estimate, that it gives us the idea maybe, of how much time it will require. Fine. The time taken, it mainly depends upon the number of lines of code. Okay. कि कितनी बार, कि how many times it has to iterate. Fine. There are a few notations which you might be aware of, like big O notation, omega notation, theta notation. So big O is for the upper limit. Okay. It usually big O is measured for, or it's for indicating the worst case complexity. Omega, it's for the, omega is for the average case. Okay. And theta, theta is for the average case and omega is for the good one. Okay. The best one. Fine. Now you have the space complexity. Space complexity means the total memory space which is required by any program for the execution of a code. So how much space a program will take to execute that particular code, that is a space complexity. It depends on the size of the data structure that you are using in the code. So what data structure that you are actually relying on for the execution or for this particular piece of code. The sorting algorithm, which takes constant space, they are, the constant which remains constant throughout, they are called as in-place sorting algorithms. And if we do not use any data structure like array, list, etc., then the code, it basically uses a constant space. And the space complexity over there becomes O1. Okay. Then, we have in place and out place for the space complexity. So now I'm moving on to poll 1, just to see how you guys are attentive in the class.
Okay, the poll has been launched. Everyone, please go forward and answer the poll so that we understand whether you are connected with us and have you understood or not. Okay, I can see a lot of them has already answered. I'll close the poll soon, so kindly answer the poll. Okay, I'm closing the poll.
That's so cool. Yeah. So a lot of you have answered correctly. That's a good thing. Now, moving on to the next part is to talk about, different sorting algorithms. So the different sorting algorithms that we'll take up today is bubble sort, insertion sort, selection sort, and if time permits, merge sort. Fine. So I'll move on to bubble sort now and how to perform that and to, work with the algorithm part of it. So I just need to go on to I'll be stop sharing and I have to open up the whiteboard for that. So for the meantime, I'll be writing on my whiteboard. I'll put off my camera, okay? So the first thing, I hope have I shared the screen? Not yet. Okay. So the first algorithm which we are starting off is bubble sort. Now, what is bubble sort? It's again a sorting algorithm. Sorting algorithm, which basically works by repeatedly swapping the adjacent elements. Okay, so you have to swap the elements repeatedly over here in bubble sort. Okay, so like it works by repeatedly swapping the adjacent elements. Okay, so after each iteration which happens, or after iteration keh lijiye, ya if you can also call it pass, the largest element, it has to reach the end. Okay, so in case of ascending order, in each iteration, the largest item, it reaches the end. Okay, or here, maybe if you're doing it descending, then the smallest one reaches the end. So this happens until the whole list is sorted. Okay, so this particular algorithm, there is a drawback for bubble sort, though it is very easy to implement. The drawback is, what do you think would be the drawback? Anyone? It's doing and it's performing so many of iterations. In one iteration it has to go and swap, and again it's comparing each and every element again and again. What do you think would be the drawback over here? it will take much time. Time complexity increase hoti hai, very nice. So the time complexity, yes, it increases. Also, it is not suitable for large data sets. Okay. The average case, the worst case complexity over here, it is O(n) square for it. Okay. N is what? It is the number of items. Okay. So the average case complexity and the worst case complexity is O(n) square. If you have to understand it with an example, let's take a small example. Okay. We have a few elements, let's say 64, 34, 25, 12, 22, 11, and 19. These are the few elements that we have. Now you need to swap it. Okay, you have to. How many iterations will be there? Total number of iterations. 1, 2, 3, 4, 5, 6, 7. So you have to perform 7 iterations. Okay. This has to go. Means you have to run a loop over here to go for 7, items there. That is one thing. So 7 iterations will come in. Now we'll start with the first iteration. Okay. So the first iteration, we have 64, 34, 25, 12, 22, and 90. Now what will happen? It is going to compare these two first. This is going to see that 64 is greater than 34. So it's going to swap. So after swapping, 34 will be here and 64 will go here. Okay. So this is the first comparison which had happened. Now it's going to compare 64 and 25. Again, what does it see? That 25 is smaller. So again, it's going to swap. Okay. Then the next time, so you see in one iteration, this is all happening. Okay. In one iteration, this is all which is happening. Now again, 64 and 12 will be compared. So 12 is smaller, then it is going to be swapped and 64 gets to move back. Now 64 and 22 gets compared. 22 will swap over here, 64 will go there. Now with 11 again, 11 will come here and 64. Now 64 and 90 gets compared. So they are already in place, nothing will happen. Okay. So after one iteration, what you are going to get? You are going to get 34, 25, 12, 22, 11, 64, and 90. This is after one iteration. Okay. On this, you are going to go second pass. Now what? You are again going to start from the top. 34 and 25. So 25 will come here. 34 will swap. Now 34 and 12. 12 is smaller. It will again going to swap. Then 34 and 22. Again a swap. 34 and 11. Again a swap. Now 34, 64 and 90, they are already in place. No swap will take place. So what is the next, now here, what would be the last thing, or what is a sorted one for this pass that we'll have? Okay, this. And so on. So this is going to continue till 7 iterations. Okay. And then you are going to get the last one, which is the sorted one, which will be 11, 12. Then you have 22. Then the next is 25, 34, 64, and 90. So this is after 7 iterations. Okay. So there are total 7 passes. So how many elements and the passes? Now, again, one thing to notice over here is when you see O(n) square, that means there are, from this we can say there are two for loops. Two loops. We cannot for, two loops. Now, if I have to do an algorithm for this bubble sort, what do we need? First, we need one for loop for all the iterations. So number of iterations means they are equivalent to the number of array items that we have, right? For I equals to 0, I is less than if n is the items and plus plus. This is the first for loop. Okay. Then why do you need a second for loop? I said that there are two loops. Why do you need a second loop over here? Anyone? Why will you need a second loop? Why will you need a second loop? For all the passes as well, right? Inside it for comparing, very good. For comparison as well, you need a loop. So, and how will that loop run? It's going to start from the first element, but till where? What will be the condition, where till where it has to go? How many elements? It will be n minus I, not till n minus I minus 1. Because if you'll go over here, you'll see after this, for the next iteration, it is stopping one before. Okay. It is only happening till here because the last element is already sorted. After each iteration, the last is already sorted. After each iteration, you are getting some sorted elements. So in the next iteration, you are not going to count those elements, right? That is why. So it is going to run till n minus I minus 1. Till j plus plus. The two loops that we have. Now you will do the comparison. If a of j is greater than a of the next element would be at j plus 1, then you can perform your swap operation. Okay. So you can do a swap of a of j and a of j plus 1. Okay. Fine. That's it. That is what you have to do. You can also take one counter here for swap. After each swapping, you can put it as 1. Okay. And if there are no more elements to swap, you can simply just stop it. Take or break out of it. So this is just a very simple n minus 1 minus I. This is your bubble sort. बहुत simple है. Bubble sort is very easy. Swapping ka case, I suppose each one of you know how to swap, right? How to swap with a temporary variable. You can take and you can swap. For a swap, what do? You have A and B, and if you have to swap it, T equals to A, right? A equals to B and B equals to T. This is how you swap. This is the code for swapping. Okay? You can utilize it. Simple. So that is about your merge sort. Now moving on, was about your bubble sort. Now moving on to the next one, which is again a simple one, which is your selection sort. Okay. Have you guys understood this? Simple sorting, bubble sorting. Have you guys understood or got this thing that why we are having two for loops over here? Yes, that's cool enough. Now we can move to the second one, which is your selection sort. Okay. Now, this kind of sorting, it basically sorts an array by repeatedly finding the minimum element, by repeatedly finding the minimum element from the unsorted part and putting it at the beginning. Okay. What it does is it basically sorts an array by repeatedly finding the minimum element. Okay. The minimum element. If you are considering an ascending order, agar aap ascending order mein you are trying to ascend, sort it there, and it tries to find the minimum element from the unsorted part of the array. And where does it put it? In the beginning. Okay. So here, what this algorithm does is it basically maintains two sub-arrays for this operation. Two sub-arrays. Okay. In a given array, whatever array we've taken, in that it's going to maintain two sub-array. And what are those? The first sub-array, the two sub-arrays are the first sub-array that you have. It is the sorted array. And the second one is the unsorted, remaining unsorted array. Unsorted array. Okay. So in every iteration, you could say, or the pass of selection sort, the minimum element. Okay. If you are doing it for the ascending order, there you will take a minimum. If you're doing descending, you will take a maximum. Considering the ascending over here, in every iteration of your selection sort, the minimum element from the unsorted subarray will be picked and it will be moved to the sorted subarray. Okay. So the selection sort, it has the property of minimizing the number of swaps. Okay. Therefore, also, it is the best choice when the cost of swapping is high. You can go for selection sort. For example, again, let's take an example to understand. You have an array. Let's take some number, 23, 78. Another could be 45, 8, 32, and let's say 46. So these are the elements, the unsorted array that you have, and you have to sort it. Okay. Now, the first pass that you'll have. First iteration. You have to find the minimum from it and you have to place it at the beginning. Okay. So the first you have to find, so the minimum is 8, you put it at the beginning of it. And whenever you do that, you have to perform a swap operation also. But if you have the minimum this and you're putting it at this place, you have to swap the position. Okay. So now the sorted would look like 8, 78, 45, 23, 32, and 46. So you need iteration. Again, you are performing search and swap. That you are searching for minimum and you are also swapping the places, to put it into the front. Fine. Now, as soon as you have it, so now you have two arrays, you see. This would be your sorted subarray, where you are putting the sorted elements, and this is your remaining unsorted array. The next iteration that you have in that, again, in this remaining part, you are going to find the next smallest element. When you have the next smallest element, you're not concerned about this part of B. So here in the next smallest element, the element is 23. You swap it. Put it at 23 here, then 45 and 78 goes here. So this is the array from the second pass. Then you have the third pass. Now this is different. Now this is your unsorted one, okay? Which is the smallest one? 32 is the smallest one. You have to swap it. So 8, 23, 32, 78, 45 and 46. Okay. So this is the sorted. This is sorted. This is again remaining unsorted. From here again, you are going to choose in the fourth pass. 45 is the smallest, right? 23, 32, 45 and 78 goes here and 46. Then in the fifth pass, again, you're going to check, see if already in place, then nothing to do. If not, then you have to swap. So now here 46 is smallest, so it has to come in front. Like this. Done. This is the sorted element. This is a sorted array, after selection sort. So how many passes total we have? We had 5 passes, right? So now understand that how will your loop look like here again? So one loop will be the first, to iterate through all the elements. You are going to start from 0, yes. But you will take notice for 6 elements, we have only 5 passes. That means it has to go till I is less than n minus 1. Okay. You have seen it from the example itself. No one told you like that. Okay. So you've seen it that how many passes we'll have? We'll have n minus 1 passes starting from 0. Cool. Now, the next is another loop. And why is that loop required, anyone? What will a second loop do? Anyone who will tell me what will the second loop do and how will it look like? Minimum number, yes. Cool. So now what you have is for the minimum number that you have to do, okay? So here for j, and this would be I plus 1. So the next element you have to go for, right? Because you've already started from the first one, you already have it. And then you have saved here in the minimum, you are going to take I, whatever is the first element that you have, okay? Then the next one starts from the second element, which is I plus 1 for it. And it will go till n again, till the last and j plus plus. Okay. Now what you have to do is you have to do the comparison. A of j, what you have is less than A of min. Agar if it is less than A of min, then in min you have to do this, reassignment. And then the whole swap will happen for you. Okay. Like t equals to A of I. So what is there in A of I right now? You are doing the swapping, the last step. In A of I, you will have A of min. And in A of min, you're going to put T. This is what it looks like. What we are doing over here is simple. Kya kar rahe hain hum? What we are doing? So first, this min, it has to be set to 0 as well initially. Now, the first thing is we are setting the minimum to 0 because we are not aware of what it is, right? The second is we are searching the minimum element in the list. For that, The first loop that we've applied is, for the iterations, for the passes. So the iterations or the passes will go n minus 1. Okay. The next is for the first loop, for minimum, we've given it or set it to the first, element in the array. Okay. Or the element in the unsorted array. Then after that, we are running a second loop to find the minimum basically and to go on to the other elements, which will be from the second element, which is I plus 1 and going till n. Now you're doing a comparison whether A of j is less than A of min or not. Okay. And if it is, then you're simply just changing the indexes of it, min to j. Then you're doing the swap operation, which is just a, 3 variable swap, which we are already aware of. T equals to A of I. And in A of I, you are basically putting the value of A of min. And if A of min, again, setting it to T. So this is your selection sort. And how does it look like? Now you tell me, is it understood? Anywhere that you think you've not understood? Bataiye, tell me what is the doubt? From here? Okay, let's try and understand this one more time. Okay. The simple algorithm, if you will have to write it, how will you do that? Agar simple algorithm mujhe likhni hai, without any of the, pseudo code or anything, how can I do that? Let me write it. And then you try and relate it with the pseudo code. Okay. So the first step that we have is where we take one variable and we set it to location 0. Okay. Then the second is what we have is we have to search the minimum element in the list. Okay. The third is that you have to swap now. Swap the value. Okay. Which is at location min. Then the fourth is that you have to increment the counter also, right? Or increment the min to point to the next element. There you do increment min to point to next element. Okay. The fifth step is the last one where you repeat, until you get the sorted list. Simple algorithm looks like this. Okay. Now working about the pseudocode of it. How does the pseudocode looks like? Because you're facing some problem in that. Okay. The first thing that you need is you have some variables like min, I, j, temporary variable. Okay, that is going to help you later. The first thing that you need is a for loop. The first, for the iterations. You're going to start from I equals to 0. I is less than, I told you it will go till n minus 1. Okay. And plus plus. The first step is where you set the minimum to the first location, which is in the unsorted array is I itself. Then the second one which you have is for the other, for the next elements that you have in the list. So j equals to I plus 1, and you go till n, till the last basically, and j plus plus. Okay. Over here, what you have to do is you will be comparing now that if a of j, is it less than a of min? Fine. If it is less than, then what you are doing is you are just setting the minimum to the next element. Okay. Matlab uska index you are changing to the next for the coming iteration. So you're updating it here. Okay. Then if it is, then what you have to do, agar aisa ho gaya hai, then you simply have to do the swapping. A of I, fine. A of I equals to A of min, and A of min equals to T. That's it. Khatam. Have you understood now? Have you understood now? Yep. So I'll be taking one more. Okay. The next that I'm going to talk about is insertion sort. Let's take insertion. Before I take insertion sort, I have a quick poll coming up for you guys.
Yes, I hope everyone can see the poll. I'll read out the poll for you. Space complexity depends on the size of the data structure we are using to do our code. Is this statement true or false? Yes, quickly answer this question. Last time only 70% of the people had answered, so I would request everyone to participate in this so that you can also understand whether you've understood the concept or not. Okay, so I'll be closing the poll. Wonderful, wonderful. Most of them have answered it properly.
That's great. Yeah. Cool. So that was good, right? Now I'll move on to the last one for today, which is insertion sort. Right now, insertion sort, again, a very simple sorting algorithm that works similarly, as you can say, to the way you sort playing cards. You might have played cards. If not, so when we play like like there are many other card games. Now I'm not kind of putting those things out, maybe like Teen Patti, Rummy, kind of those things. So when we play cards, we have to sort the playing cards in our hands, right? We'll sort them, we'll put them, we'll arrange them in our hand, and then we'll try and sort it. So the array is this insertion sort. It kinds of work in the similar manner, and the array is virtually split into a sorted and an unsorted array, or you could say a sorted and an unsorted part, and values from the unsorted part are picked and placed at the correct position in the sorted part. Insertion sort is fast, and it's also suitable when the problem size is small, okay, because it has low overhead, or when your data is nearly sorted, because it's kind of adaptive. It's not much, it's not kind of a jagged type of thing. So it's nearly sorted, but only a little bit of sorting is applied or is required. There you can use insertion sort. Now, how it works? Okay, it's an in place. You could say it's an in place. sorting algorithm. And it's based on comparison. So it's a simple algorithm where there is a sorted sublist is maintained by entering an element at a time. An element which is to be inserted in the sorted has to be, it has to find its appropriate location. You try and find the appropriate location, and then you insert that element over there. Okay. It is not suitable for large data set, only suitable for some small data sets only. Okay. The average complexity is ON2, where N is again the number of items over here. Okay. So an example to show this, let's work on that. Suppose we have an array 9, 6, 5, 0, 8, 2, 7, 1, 3, 4. Okay. So this is kind of an array that we have 9, 6, 5, 0, 8, 2, 7, 1, 3, 4. Fine. Now you need to arrange it, right? It will go from 0 to 9, I suppose this one. Now you have to use a for loop over here. You have to use a loop and you have to start from it. Okay. So starting from the first one that you will see. So we are going to start the loop for I equals to 1 from the second element of the array till the last element. Okay. We start from I plus 1 till the last element. Fine. Now here we see the element at the second position and then we compare it. Okay, because we have to compare from the first one, why to start from there. So we start from I plus 1 till n, then we compare the second one and we see that 6 is less than 9. If it is less, we, insert 6 before 9 now. Okay, this is your I1 or iteration 1. Okay, so here what do you do is, you compare 6 is less than 9, and if it is less than 9, then you insert 6 before 9. Then comes, this is your first iteration. Then is your second iteration. Now you already have 6 in front. Then you do it for I equals to 2. Okay. I2 means you have to go to this place. Now what do you see is 5 is smaller than 9 and 6, right? So you have to put it in front of 6. Like this. And so on. This is how the insertion goes. Then for the next iteration, you go on to this, I equals to 3. You see 0 is less than all of them. So you insert 0. Okay. Then the next is 8, I equals to 4. This is your I equals to 4. Here you have 8. You check from 0, 5, 6, 9. You say, acha, it is less than 9, but obviously coming greater than 0 and 5 and 6. Then you put it in place. Okay, 0, 5, 6, 8, and 9. And so on, you sort the whole array. How many passes we will have? We will have starting from 1 here. We have 1, 2, 3, 0, 9. 9 passes. Okay, total number of iteration is 9. Starting from 1 going till n. So at the end, you will have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9 sorted. Now, how does it look like? How to work with it? Or what is the algorithm behind it? Okay. So the first thing here, what happens is, the first step is, if it is the first element, we take it, it is already sorted. Okay. If it is, because we don't start it from there, we go to the next one. If it is the first element, we consider it sorted. Okay. Second is, pick the next element, the second one. Okay, from the array. You have to compare with all elements in the sorted sublist. Now, The third step is this particular element, the next element, it has to be compared. The comparison happens, okay? It has to be compared with all the elements which are there in a sorted list or sorted subarray. You do the comparison, okay? Then you do the shifting, yeah, insertion. Okay, so you are going to shift all the elements in the sorted sublist which are greater than the value, okay, to be sorted. And then you insert. And then you insert the value. You are going to repeat until the array is sorted. Okay. So this is what a basic algo looks like, that, how to start with it and how to work on it. Here again, to start with, you'll be using two loops. Okay. The first loop you are going to run from, from 1 till length. Okay. That is your first loop. So if you have to work on the pseudocode of it, you are going to have a first loop, which I already told you. You are starting from 1 and you're going till n. Okay. N means is the length. Then the next is, what do you do over here? You have to do the comparisons, right? So for the comparison, we are going to take a variable which we are going to use, which will hold the element, okay? So j equals to I, the array element. Now you're going to check while if your j is greater than 0, okay, and also a of j minus 1, okay, which is one less than maybe an element which is before it, okay, j minus 1 is greater than a of j with the value that you are trying to compare. Agar aisa hai, then you have to do the swapping. You see, yahan pe bhi we have to swap. Okay, so you swap them. Okay, a of j and a of j minus 1 ko swap kar do aap. And then you do j minus minus. Fine. So this is what your simple pseudocode looks like. Okay. That you start with a for loop. The first loop is for all the passes that you have. So you're going to start from I till the length itself. Then, the first element that you have in the array, you have to assign its place and take it into a variable j. With that only you are going to do the comparison. Okay. Now you are going to run a loop until you have j, which is either becomes 0, then only you are going to stop it, or you are going to also check for, and you're also going to check for if the element at j minus 1 is greater than, means 1 before is greater than, yes, the next element, which is the a of j itself. If it is, then you have to swap and you have to decrement your j minus minus. Okay. This is what your insertion sort looks like. Understood? Anywhere you're not able to understand? Understand? Very cool. Now coming towards the end of our class, we have, kind of discussed 3 important. Now, these are the important, when I say important sorting algorithms, because they kind of come up a lot in the interviews, that's why we are putting an emphasis on it about the importance, how important these algorithms they are. Whether you talk about, I also wanted to discuss a few more, but due to the time constraint, we'll be limiting it right now. Maybe in the another session that we'll take, we'll discuss other sorting algorithms as well. Okay. Now, before we try and move towards the end of a session, there is another poll which is coming up for you guys.
Okay, the poll is live. I hope everyone can see that. And I'll read it out for you. What is the average and worst case time complexity of bubble sort? Yeah. Everyone can quickly answer that. Perfect. I'll be closing the poll. Okay. Again, 85% of the people have answered it correctly. Wonderful.
That's great, each one of you. So we are towards the end now. Anyone who still has some questions?
No questions so far.
So on an ending note, there is kind of, the only thing that sometimes I get from students is that how to, apply these, or maybe how to identify the algorithm and, use where to use which one. So that only comes with practice, each one of you. And if you kind of are confused, because when we also started doing these algorithms, we were only thinking, so many algorithms doing the same task of sorting, but still we have so many. So how to apply, or where to identify. So that only comes with practice, and there are different, you will have to study time and space complexity of each one of it to understand, in which scenario one suits the best. So in conclusion, I can only say that we got an in-depth idea about certain, sorting algorithms over here. And just to recap, what we've learned throughout is that we've talked about sorting, that what sorting means. Now, sorting means that arranging our data into a particular order. It could be ascending, descending, or whatever. And we have ample sorting algorithm to perform this task. Okay, there are many. Fine. And the time and space complexity. So the time complexity of sorting algorithm, it basically determines the overall estimate time which will be taken by the algorithm to run and execute, or maybe complete, and the input size, if the input size is n. In place sorting, the space complexity is how much, space does it require on your, system. Right? And there are two, which is in place and out place again. In place means when the sorting algorithm does not use any extra memory for sorting. Okay, where out of place sorting, it requires extra memory. Okay, so these are some of the things that we've discussed. We've talked about that, there is always a trade-off between time and space complexity. Okay, that you cannot achieve both of them at the same time. But there is something, a kind of a trade-off which always happens. And we've done bubble sort, selection sort, and insertion sort today. Okay, hope to connect in future lecture again, and we'll talk about other, different sorting algorithms one by one. So that's it from my end.
Okay. Thank you so much, Swati. I would like to thank Swati for taking this session wonderfully and patiently, more so, and answering your questions. I hope everyone would agree that Swati ma'am took a very good session. And on that note, I would like to begin by thanking you guys first, because on a Saturday morning, you've taken out time to join and upskill yourself, learn something new, right? So, a big thank you to you guys as well. Now, I would like to draw your attention towards the program that we have to offer, right? At Unique Aksha, basically, Unique Aksha is an upskillment platform, right? Where we help people to transition into tech companies, top tech companies. We train them, right? And give them all the necessary skill sets that are required to get into top tech companies, right? So there are a lot of USPs that I would like to point out, but one of the USPs, one or two USPs that I would like to point out would be that we are an upskillment platform where you get people from the industry who are training you. So the key USP here is that we have people from the industry who have a good amount of experience. These are the people who are going to train you, right? And you're going to get that hands-on skill sets that is required. Secondly, all our classes are 100% live classes, right? So that you get to interact with people and not just sit in front of the screen and look at the screen, right? So it's a two-way communication that happens. Thirdly, we are an end-to-end program, which means that we start with upskillment, but after upskillment, we venture into resume building also, mock interviews also, and finally helping you get placed as well, right? So that is just a brief about our program into full stack development. If you wish to know more about the program, or if you wish to join our program, I will be launching a poll now. Right, kindly answer it if you want to, if you are interested to know more about the program. Perfect. I'll be ending the poll now, and okay. Perfect. So thank you so much for your responses, and those who have answered yes, our team will connect with you, right? And that's about it. And thank you so much for connecting. And I wish to see you for the upcoming Guru classes as well. Thank you so much.